Hey everyone, welcome to the Weekly Space Hangout for Friday, May 20th, 2016. I'm Fraser Cain, publisher of Universe Today, and we have got a pretty great show for you today. Some of my favorite people, well, okay, so one I've talked to a whole bunch, one I've never met, but I think if we average it out, they are my favorite people in the space community, are joining us this week to talk about one of the topics you've all asked for them, and I will let you know who it is in 1 second. But before then, we've got one of our regulars, Julian Creighton, who is joining us from Futurism. Hey, Julian.
Hello, Fraser. How are you?
Good. Thanks for joining us in the new environment that we're running.
Indeed. Very exciting.
All
Very
right.
excited for this new environment.
And you've got some stories that I'm not entirely sure what we're going to be talking about. Something about extraterrestrials, something about mega tsunamis.
Yes, basically aliens and large tsunamis. That's what we're going to be doing. Very exciting things.
That sounds fantastic. All right, well, let's get on to the special guests. All the way from CalTech, California, we've got Konstantin Batygin and Mike Brown, who you might recognize as the people who turned up compelling evidence that there is a ninth large planet in the outer solar system. Welcome to the Weekly Space Hangout, guys.
Thanks, Fraser.
All right, so I gave you a terrible introduction, so why don't you provide a more detailed introduction for who you guys are and what you do?
Well, I mostly get coffee around here, and occasionally I write down an equation or two, and one thing leads to another, and we end up looking for planets.
Something like this. And I mostly look through telescopes and see what he does when he writes down equations. So it's a good combination of people who write down equations and people who look for telescopes if you're trying to figure out where to point your telescope to look for some of these big things out there.
And for people who maybe have no context, Mike, you are, of course, the person who killed Pluto. And by killing Pluto, really, that was just... Yeah, well, okay, you were the person who discovered Eris and other dwarf planets in the Kuiper Belt.
I would say I am one of the people who helped us to our new understanding of Pluto's place in the solar system as part of this newly discovered region of the Kuiper Belt. And Pluto is much happier with its own kind.
As a dwarf planet.
As
right.
a dwarf planet.
Yeah.
And as the dog. It's better among the dogs.
But I think that for you, I mean, finding icy objects in the outer solar system really is the core of what you've been working on. So can you give us some other context, some of the other projects and stuff that you've worked on in the past that sort of brought you to this place?
Yeah, so really all of this started more than 15 years ago now with the first big survey that I started looking at the outer solar system, looking for the largest objects that were still left to be discovered. It was at the time when Pluto was the largest of the Kuiper Belt objects, and it was kind of the only one of its size known. And it seemed pretty clear that there must be some other large ones out there. So we started this big survey, found all these ones that you know by name, Eris and Makemake and Haumea and Orcus and all those guys. And that is really what led to this big revolution in our understanding of what's out there. And what was interesting, and I didn't anticipate at all, that's what also then led to us realizing that that's not the edge of the solar system, that the solar system continues on, and that there must be this Planet 9 even further out there.
And I know that another part of your fascination is just this idea of ice and what the ice means in the outer solar system. And I a lot of the research that's coming back these days is that there are there's a lot of these icy bodies. They're a lot more dynamic than anyone ever really expected. Sort of where are we at our understanding of what's going on with the solar system and with the icy objects out there?
So the idea that they're more dynamic than expected is something that people say from looking at these Pluto images. And I would just like to point out that they are as dynamic as we expected. We knew that Pluto was going to be crazy like this. And the reason is because Pluto is mostly made out of frozen water with some rock on the inside. And on the outside of this frozen water, there is frozen carbon monoxide, methane, and nitrogen. And those three ices on Pluto are just the right temperature where they sometimes will melt, they'll sometimes go into the atmosphere, they'll sometimes flow. And so knowing that about what was on there, we knew it was going to be crazy. We knew there would be all sorts of dynamical sort of atmospheric effects going on, surface effects. What we didn't know is what those were going to be. So it was still a big surprise to see that, but it's absolutely not a surprise to see that these things are active, interesting worlds.
All right, so Konstantin, let's talk about the math. How did you get into this and to the search for larger objects in the outer solar system?
Well, it's interesting. I actually started working on the entire problem from the point of view, and this is actually back a few years ago now, that when Mike and I first began thinking about the outer solar system together, we started thinking about how did the whole thing form, and trying to use the constraints that we see, the orbital structure that we see in the Kuiper Belt, to back out, to sort of derive the dramatic history of the solar system itself. And really, it was kind of a natural transition from that into the continually trying to understand the various features, where we stumbled upon something that really did not fit in at all with the 8-planet solar system that we had. And this was, of course, the fact that most of the distant orbits were all facing into the same direction. And that was really our transition point. We used to work on trying to understand how the solar system formed. When we more or less understood this problem, we kind of transitioned into also seeing that the pieces are not fully there.
But this technique of using math to infer the location of an object that you haven't seen directly yet, I mean, this has been done for hundreds of years, right?
Well, indeed. In fact, this has been done unsuccessfully for 170 years now. But there is one kind of beautiful example of such a success, which is the discovery of Neptune itself. Neptune was predicted through mathematical modeling in 1846, based upon the fact that Uranus was not exactly following the trajectory that it was supposed to. It was deviating from its course, and this was explained by the gravitational influence of a distant planet. And of course, this was came to fruition in a fantastic confirmation of theoretical results by observations. Since then, numerous mathematicians and astronomers have tried to repeat this example, and although we have been successful in doing this in the exoplanet realm, right, we find exoplanets based upon the gravitational signature they exert upon one another all the time. In the solar system, this had really been a failure in the last 170 years. I think that these new orbits in the Kuiper Belt are really the first evidence in a very long time that the solar system's catalog is incomplete.
Mike, what does an object like this, something that is like maybe Neptune sized, out in the really outer solar system now, what does this tell us a bit about the formation of the solar system, maybe what we didn't already know?
Well, it's interesting because Konstantin started telling the story about how we first were looking at the formation of the solar system, formation of the outer solar system, how to put the Kuiper Belt objects where they were. And one of the things that we explored was what happens if you have a fifth giant planet core in the region where Jupiter, Saturn, Uranus, and Neptune are. There's no reason that there couldn't have been a fifth or even a sixth or seventh core that formed in those same places. And we realized that if you put one in there, most of the time that fifth core gets ejected to the outer part of the solar system. Now, we stopped thinking about the story right then because we were only thinking about how the solar system formed. But once you realize that you can eject these things into the outer solar system, it's not crazy to then think that some of them could have gotten stuck out there and have been lurking for these past 4.5 billion years. So it kind of puts together this story that we've been working on for almost a decade and makes us realize where all the pieces are.
Right. So we know, and we've seen from these extrasolar worlds that there is a lot more planetary migration than I guess anyone ever really expected before they start to turn up these hot Jupiters and worlds like this. And so it really kind of helps answer that question. Was you get this shuffling of planets, where did they go? Can you still find them? And what happened with the solar system? So in this case, they're all still out there. We just threw them out into the outer parts of the solar system. We didn't throw them out entirely.
And it's possible that some of them were thrown out entirely too. So that's easy to do also. And so so some might be roaming the galaxy, and some might still be out there.
That's right. And it's not actually clear, right? It's not clear where exactly Planet 9 came from and when it detached from the conventional, what we now call the inner solar system, which is everything inside of Neptune, Neptune included. So it's, the origins of Planet 9 is something that we think about all the time and we argue about it, but really at this point we're just speculating. Until it's caught on camera, it will be difficult to make any definitive claims about how it formed.
So I have a question, because we just mentioned catching it on camera. How likely is it, and how long would it take us to try and actually do that? And then sort of extending from that, how likely is it that perhaps there's a planet 10 and 11 sort of lurking out in the outer solar system?
So the search for Planet 9 is well underway right now, and even if it's at its furthest distance, so it's on a very eccentric orbit, and on that very eccentric orbit, at its furthest distance, it can be 1,000 or 1,500 AU away from the sun. But it's big. It's at 10 times the mass of the Earth. It's probably only a little bit smaller than Neptune. So it's actually not that faint. Even at its furthest distance, well, by not that faint, that's not that faint to me. It means that it's the sort of thing that you can find with the biggest telescopes in the world. So it's still going to require the biggest telescopes in the world, but it doesn't require a telescope bigger than one that we've ever made. So this means that the search is going to eventually turn it up. I think it's going to take somewhere between 2 and 4 years before we find it. And I'm pretty confident in that time it'll be out there.
I think what Mike is saying is that the prospects of finding it within the next decade are not as dim as the planet itself.
I
think that's what you mean. That's like subconsciously. No. That's exactly.
What about Planet
10? Planet 10. So it's a funny thing. The solar system has plenty of real estate. Right? You can park planets as far as you want. The sun's gravitational sphere of influence ends at 100,000 AU, roughly.
A couple of light years, yeah.
Yeah, at 1,000. But there's actually a problem with parking planets further and further, which is that once you're far enough away, even though you can orbit the sun formally, you will get stripped away by passing stars. And the limit on that is not too much further than the current orbit of Planet 9. So Planet 9 only has about a 50% chance of survival over the lifetime of the solar system. Now, 50% in astronomy is pretty much equivalent to 100%, but it's
to zero,
whichever
one you want.
But what this means is that sort of 1,000 AU is that transition point. You park something at 10,000 AU, it's going to get stripped by passing stars. So I don't think there's another massive 10th planet out there. But I've been wrong before.
Right, but you feel like that's the other end of the search zone. Like once you get beyond that 1,000 AU, that the chances of something being stable for any long period of time is pretty low.
That's right.
The other thing is that if there were a Planet 10, and I am less pessimistic about a Planet 10. I think that there's room that you could put a Planet 10 out there.
You could put in 3-2 resonance with Planet 9.
You could actually. You could do that.
That's true.
But if you did put a Planet 10 out there, the way you would know is by looking at the gravitational influence on things that go out that far. That's how we know that Planet 9 is there. We see the influence on the Kuiper Belt objects that go out that far. The problem is we don't know of any objects that are that far away currently, and if we did, they would be super faint, as would be Planet 10, because it would be so further out. So unlike Planet 9, which I said we can find with our current telescopes, Planet 10, if it exists, will require the next generation of telescopes and the next generation of people. When I'm talking to kids about this, I always explain, Planet 9 is kind of our generation's planet to find, but Planet 10 and beyond is all of you guys.
Well,
sorry, Renan, it's a comment from Facebook. So Renan, sorry if I'm saying your name wrong. So it's asking about the location of Planet 9. So could you speak maybe a little bit more about how we know specifically where it is and how we would differentiate it from like the stars? Because I know I heard before they would move really, really super slowly, so it could be easily mistaken for something else. So just maybe speak to that a little bit.
Okay, yeah. So we know the orbit of Planet 9 from theoretical calculations, and the calculations go as follows. We start out with a solar system 4 billion years ago with a Kuiper belt, which is entirely randomized, and we evolve it under the influence of Planet 9 and the other planets for the lifetime of the Sun. And we watch where the Kuiper belt objects go. Now, as it so happens, if Planet 9's orbit faces one way, the stable Kuiper belt objects end up facing the other way. So they're kind of interlocked, and their major axes are diametrically opposed. Based upon this, we know, and of course we know where the real Kuiper belt objects are. We can simply, envision drawing an orbit, a putative orbit in space, and that basically tells us where Planet 9 is, especially given that it's likely at the furthest point from the Sun at the moment.
Well, I'd say, yeah. So it doesn't tell us where Planet 9 is. It tells us the path that Planet 9 travels across the sky. So we now know a swath across the sky, but it goes all the way around that we have to look for. But we've actually ruled out about 2/3 of the sky so far. So we only have about a third left. And the way we'll find it, it's actually, it moves slowly, even when it's at its most distant. But it's actually a really almost ideal speed that it's moving. It's moving the speed where if we take a picture of the sky one night, we come back the next night and take a picture of the same patch of sky, it will have moved just by enough to make it easily detectable. It won't have moved really far, which would make it hard to track down. It won't have just barely moved. It'll be perfect, and it'll be really obvious. I actually think that the day that we discover Planet 9, we will just look at these images as they come off the telescope the second day and just know right then.
Yeah, and when it comes to where it actually is in the sky, it is in the absolute best part of the sky. I don't know many constellations, but I know Orion because my cat's name's Orion, and it's in Orion's shield or sword. So it's furthest from the Sun. It's aphelion, where it spends most of its time is right there at the edge of the shield, and then there's a swath kind of on either side of that where we're going to be doing the search.
So it's just passing right in front of some nebulosity right now, and so you just can't see it.
That's always one of those things that we're paranoid about. To tell you the truth.
So I got some questions from YouTube on this one. So this one comes from William Van de Beek. Do you have a planned name for the object?
There's a change.org petition, which I will ask you to not sign.
Okay.
Which is to name Planet 9 David Bowie. And
but I think we decided on Prince instead.
That's right. Yeah.
And that's because you would prefer the name Prince.
Well, yeah. Mike prefers Prince. We have to also work in Lemmy in there. He also died around the same time.
Yeah, that's a pretty serious choice between the three. I understand.
That's right. Yeah.
And then the IAU is going to want to get involved.
Yeah, we might let them. We might not.
In relation to that, I was actually wondering, so if we do, okay, there's Planet 9, hooray, we found it. What does that mean for planetary classification? Will the International Astronomical Union have to sit down and rethink what is a planet?
No. So Planet 9, it's not just a little bit bigger than Pluto. Planet 9 is 5,000 times more massive than Pluto. Planet 9 is, it's nearly the mass of Neptune. We find it by its dynamical signature in the solar system because it has cleared out everything in its region except for these things that it's locked into place. There will be zero debate about whether it's a planet or not. I don't think it's going to be a problem.
Okay, so Planet 9, definitely a planet. Pluto, definitely not.
Yeah, life is easy.
There's a quantitative criterion for it, which was derived by Jean-Luc Margot at UCLA, and it's a good formula. And by this equation, Planet 9 passes with flying colors.
Okay.
And then Earl on Facebook wanted to know that if we were ever going to do a flyby, so like New Horizons 2.0, how long would that take? I guess to get there and then actually to make the thing, because that would probably take a long time as well, I'm guessing.
So with the current technology, it would take for how long did it take to get to Pluto? I don't remember.
10 years.
Yeah. 15 years?
10 years. 10 years.
10 years. And so this is probably 20 times further. So that's 2 centuries, which is too long.
Right. So we'll need a star shot. We're going to need some kind of light-powered solar sail.
Or having nothing to do with Planet 9, I've actually been working with this group at JPL for a couple of years on some advanced technologies for getting places fast. They're interested in maybe going to nearby stars. I'm interested in getting to some of these Kuiper Belt objects. Other people are interested in getting really far away so you can use the sun as a gravitational lens to look at other things on the other direction. All sorts of crazy reasons to want to do it. And the trick is you leave the Earth and you go do a gravitational slingshot by the sun instead of by Jupiter. And as soon as you're closest to the sun as you can be, you full speed on all of your rockets, and you can actually get going really quite fast. The closer you can get to the sun, the faster you can go. And so right now, the technological hurdle is as much the shielding to keep you from burning up when you get close to the sun as it is to getting going fast. But at that point, you can go tens of AU per year. So it still may end up taking you 30 or 40 years, but it's the sort of thing that if there is a Planet 9 out there, we will want to go see it. And I think it will be the incentive to develop these super fast drives to get out there.
Yep.
Yeah.
You will be to just light all the fuses at once.
It actually really is the key.
Yeah. Well, I'm not sure if you've seen that new proposal that came out from Stephen Hawking and Yuri Milner about these star shot. And it was these tiny little, couple of meter solar sails powered by lasers. I call it bug zapping your way across the universe. But I think that the trick is, they're proposing to use this to get to Alpha Centauri, but it actually would be a wonderful way to get around the solar system where you don't have to ignite your spacecraft, try to get them to 20% the speed of light. Let's just go 1% the speed of light and visit Planet 9 and visit Pluto in a couple of months instead. But let's start somewhere.
They don't carry much, because if you're gonna be propelled just by the photons being shot at you, you're not gonna carry much instrumentation along the way. So I still think, I would love to do them, get there fast, do a very, very quick reconnaissance, but eventually you want to put some serious hardware there to see what's going on.
Genetically modified water bears.
I don't see a problem.
I don't think we even need to genetically modify them.
Yeah, they are ready to go. I know they are ready to serve.
That's
They
right.
got to be supersized.
Yeah.
I think they get bigger when you put them in water.
So I got a question that comes from Truck Captain Stumpy. Could Planet 9 be multiple objects as opposed to one object?
Well, Truck Captain, I think it's exceedingly unlikely. When it comes to the gravitational pull that is exerted upon the distant orbits, we actually considered the scenario where maybe this is actually a full belt of debris which is sort of self-modulating, right? Maybe we thought what's going on here is that it is the mean field of a massive belt, and as it turns out, that doesn't really work. You need this gravitational pull from a distinct, unique single object because of the way that the physics works out. You need that set of impulsive kicks from a single object to make it work.
But what would work is if you, instead of a 10 Earth mass planet, if you had 2 5 Earth mass planets orbiting around each other. So that would work perfectly fine. That would act the same as a single one. Now, how you would ever get 2 5 Earth mass things orbiting around each other seems kind of impossible, but at least theoretically.
But you have to also then convince yourself that the 5 Earth mass planets will be at an orbit and have tidal dissipation factors that are sufficiently large so that they don't decay upon one another.
You have to worry about that.
Yeah, could you start working on the math right now, Konstantin? That would be great.
Yeah, actually, I can actually work this out.
But the other possibility, of course, is moons, right?
Oh yeah,
I would say we don't know whether it would have moons or not, but certainly every giant planet that we know of in the solar system has moons, and I hope it has moons, because if it has moons, having moons is, of course, the best way to get the mass of the object once we find the moons and we see how long they take around to go around. If it has moons that are sort of the size of the Galilean satellites, they will be easily visible in Hubble Space Telescope images as soon as we find it.
Okay, so now your last round of discovering that happened back in the 2000s with Eris and those class. I remember you were saying that you had sort of reached the limits of the current capabilities of the instruments that were out there, that you had looked in all the smart places using the best telescopes that you had available to you, and you had pretty much rounded up all of the large objects that were out there. With Planet 9, you're sort of moving to a place where you're using math to do your discovering now and the observations based on its influence. But there is hopefully a whole new round of observatories that are going to then ideally lead to another round of discovery. So I'd like to talk about what new instruments are coming out that you're particularly interested in and you've already put your name onto the wait list.
So the most amazing instrument that's currently out there in telescope that's currently out there right now is the Subaru Telescope, the Japanese national telescope on the summit of Mauna Kea. And it's a big telescope. It's an 8-meter telescope. Most of the big telescopes specialize in different sorts of things, and the Subaru Telescope has decided that one of its specialties is going to be taking pictures of wide swaths of the sky at once. And if you want to survey a large part of the sky looking for faint objects, there's nothing like the Subaru Telescope. So they have generously let us use it a couple of times, and now that everybody knows that it's going to be the prime instrument for looking for Planet 9, we're hoping that we can get on there for a substantial chunk of time to scan those regions of the sky. So that's currently what's going on, and currently, without a doubt, the best telescope out there. Coming up in the future, in 2022, I think, is the LSST, the large-scale Synoptic telescope, is kind of, I like to think of it as it does what I did 15 years ago, but it does it on steroids. So 15 years ago, we took the small 48-inch telescope at Palomar and put the biggest astronomical CCD camera in the world on the back of it and took pictures night after night after night of the sky. And after about 5 years, we had covered the entire sky. The LSST is a bigger telescope. It's about a 6-meter telescope. It's got a monster camera on the back of it, and they're going to cover the whole sky something like once every 3 or 4 nights. And there will be it's amazing what's going to be there. And you asked the question whether or not I've booked my time on it, and the answer is I don't need to, because every photon that comes down from the LSST is instantaneously public. So everybody has access to all of the data.
Everybody has already booked all of their time because everyone's going to be getting access to all of this data.
Right.
I mean, not just, it's funny because I talk to astronomers in every field, not just the planetary astronomers, folks like you, but I talk to the supernova people, I talk to and they're all excited about what is coming with the LSST, that there's a whole new revolution, that the night sky does things that we weren't expecting, that we would never see until we started waiting to watch it change.
Yeah, it's sort of movies of the night sky, all night, every night, which is pretty cool.
Yeah. Cool. Well, we're sort of wrapping up the time that we have to talk to you guys today, but I wanted to give you a chance to sort of let people know where they can find out more and how they can sort of learn more about this ongoing process. So where can people follow you on the social medias, etc.?
So we are both on Twitter. Mike is on Twitter as @PlutoKiller. I am on Twitter with a much more creative handle @Batygin, Batygin.
Somewhere down here.
Yeah. And Mike, of course, is a best-selling author of share your book.
Let's see the book.
So I got reviews on it. Here's my book. It's a few years back. There it is. My 10-year-old daughter just started reading it last night, and she got halfway through it in one day, and I asked her how she did so quickly, and she said, I skipped the boring parts. So it's maybe 10-year-olds don't think it's that exciting yet, but
no, but it's a good book.
Did you read?
I read it. Yeah, I read it.
Did you get it at the library or did you buy it?
Actually, I think you gave me a free copy. I got a free signed copy from Mike.
Yeah.
Wow.
So it's a good book. I haven't written a book, but if you do pick up Scientific American this month, then
That's right. You're on that.
Yeah, our story is on the cover of it. It's called Born of Chaos. It is both an autobiography of mine, and it is also a story about how this
a sweeping tale of history about your life. That sounds great.
There's a nice on Astronomy magazine. I wrote the cover story for the June issue on Planet 9. So if you want to read more about Planet 9,
oh, fantastic! Written by you.
Written by me.
I know of some great new media publications that would love to have articles written by you. So maybe we can talk. And I'm assuming there's going to be a round of cool documentaries coming as well as.
I lost track, actually. There's a Discover. Who were those people last week?
Discovery Science.
Who's that? Who were those people last week?
Discovery Science.
Okay.
Yeah, there's Discovery Science.
I mean, not the same. Okay. So we don't know. We talk to people. We don't know who they are.
Yeah, I know.
But they're importantly,
NHK from Japan
is coming next week. Yeah, which is going to be good.
There was a great one from the BBC, Sky at Night. They were here 3 days after we made the announcement. They were here doing a whole episode. So there's a lot out there. You can find a lot, and there are new scientific papers on Planet 9 are coming out really weekly. It's been quite exciting to see how on board the community is, and how excited they are about making calculations about it too. So we're learning more all the time.
Yeah. Well, it's always a pleasure to talk to you, and I would love to sort of set some time aside 4 years from now, when we've actually got some images, and we will have another conversation where you get to just congratulate one another on finding another planet.
Or we'll be celebrating.
Yeah.
Or we'll be congratulating.
There will be congratulations. Well, that's fantastic. So thank you guys for joining us today. I'm really honored. I know the community is really happy to talk to you directly, and good luck with turning up the final evidence that you need. I can't wait.
All right, thank you for having us.
Thanks a lot.
All right, we'll see you later.
Bye.
All right, so now you get to reconfigure the... So we're going to dedicate today's episode, one of the Weekly Space Hangout Crew. This is, of course, the community of fans who watch this show, who really participate and make this show what it is. Guido Bibra, one of our longtime fans, his mother passed away, and she was quite a big fan of the show as well. So we just wanted to dedicate this show to Guido's mother, and thanks for both Guido's support and his mother's support. We really appreciate it. So. We're going to move on now that we're down to our final, the final participant. It's just me and Jolene, and we're going to continue on for the next 10-15 minutes and talk more about some of the other cool stories that you picked up. Man, really lucky. You got a chance to jump in there. Lots of questions for Mike and Konstantin. What a treat.
It was pretty fascinating. It was amazing. Gotta be honest, it was.
Yeah. And now you can just call them and get more quotes and stuff directly from them.
Indeed.
So where would you like to start? I know you had a couple of stories that were rattling around your brain. Where should we begin?
Yeah, so aliens and tsunamis. Those are the two.
Don't make me choose.
You do eeny, meeny, miny, moe.
No, I choose aliens. I will always choose aliens.
Okay, great. So it's actually, there was a meeting in I was in Puerto Rico this past week with a whole bunch of SETI people and astrobiologists and evolutionary biologists who were getting together to talk about alien life, how we might communicate with it, whether it exists, sort of all that fun stuff that everyone loves. And so one of the more interesting talks and papers that came out of that, I thought, was looking at how likely it is that if alien life exists, which there seems to be a general consensus that it probably does, that it will be at all like humans. And what's meant by that is, Star Trek, we see the Klingons and the Vulcans, and they speak like us. They have 2 arms and legs. They communicate and think in basically the exact same way that we do. And so the paper basically is asserting that although general intelligence, so tool use, the ability to work in social groups is probably fairly common, because we see that basically every species on planet Earth is able to survive and thrive because of having at least some baseline knowledge and intelligence. Human level intelligence actually is not really necessary. So out of all of the millions and millions of species that existed over the course of the history of our planet, there is precisely one that has intelligence that operates in the same way that we do. The author refers to it as exaggerated, I can say that word, exaggerated intelligence. And basically that means the ability to have abstract thought. That's really what this paper argues sets us apart. And basically asserts that this intelligence arose only about 250 to 50,000 years ago. Not sure the exact timeline there, but that's fairly recently. And that it likely came about because we see in every other species on the planet that they don't need to have this level of intelligence in order to survive and thrive quite happily. So it likely came about just as a result of sexual selection. And if you don't know what sexual selection is, it's basically the peacock's really bright tail. So something that's pretty and fantastic and wonderful, but really not at all necessary to survival. It doesn't have to do with fitness or anything like that. Just sexual selection has no real key role. And they're arguing, the paper argues, that human intelligence, although it allows us to thrive in unique ways, from an evolutionary standpoint, when we look at other species, what we see on Earth, it's likely that it has really little to do with our specific ability to survive and thrive. It just has to do with what mates prefer. And so, although we might find aliens, they're not going to be like us. They're probably going to be more animalistic and have just sort of a different type of intelligence.
Or not even animalistic, right? That they would be bacterialistic. That they would be right. That they would be a whole other level of I guess, I don't know, simplicity, but also just sort of ruthless evolution towards their niche. I mean, I am, if you've watched any of the videos that I've done, I am really interested in this idea of the Fermi Paradox, right? That if the universe is big and the universe is old, and there's nothing in the laws of physics that necessarily say that we couldn't travel from star to star, where are all the aliens, or where are all the robots, at least, that are, with their star shots and their, with their water bear crew compartments zipping around the cosmos, and we just don't see them. And so there's this idea, right, that complicated life, life capable of perceiving other stars, about considering the idea that there's life out there and even traveling to it, is rare, or maybe even unique, that it's just us, and that instead that we've got this universe filled with slime molds and bacteria and other kinds of life form that just haven't gotten the wherewithal to be able to consider and ponder their existence. I mean, this is one of the other ideas, right, that we have been broadcasting our existence here on Earth for about 500 million years. I mean, not even us. It's been the life forms that came before us that we're putting out oxygen and methane and even in the last few hundred years we've been putting out pollution. And you could tell, an alien star system, with a good enough telescope, and a Mike Brown level of observational experience, could say, oh, there's life there, and they're putting a lot of greenhouse gases in there. So where are they, and where are their robots? So this is, and it's interesting to me that they have all these, they make, the scientists, when they consider, like, where are the aliens, I think this is a great example. They just consider all of these, they take these things as given. Like, at some point, there's going to be multicellular life form, and there's going to be some version of mitochondria, and then they're going to have sexual selection, just like we did. And it's entirely possible that each one of these things are unique events that will never happen again.
Yeah, one of the another interesting paper that came out of this conference, it was talking about how it's entirely likely that the senses that exist in alien species might be completely and totally different than our own. So, for example, depending upon if you're on a planet that is tidally locked, where one side of the planet always faces the sun, one side always sort of faces outer space, always dark. Species would probably live right in the twilight zone, so on the fringes, in which case the paper was arguing you wouldn't really need to see the electromagnetic spectrum. You wouldn't need to receive light. And so extending from that, the ways that we communicate, hearing, all of these various things could be completely and fundamentally different in any intelligent species that did happen to arise. And so if that's true, if the way that they sense the universe is completely and totally foreign to us, it's kind of like trying to imagine a color that doesn't exist, because all life on Earth seems to sort of share these commonalities. And so how would we communicate? So if we did find them, the chances of them being even remotely like us just seems so abysmally small, at least this paper was arguing, and I kind of find that a relatively compelling argument that this ship or whatever it is arrives, and there's just no way that we can interact or register in any meaningful way. And so Contact, Carl Sagan's awesome movie and book, they communicate using prime numbers, but ultimately you're communicating via sound using prime numbers or via sight using prime numbers. If you can't even sense the universe in the same way, how do you do that?
Yeah, I mean, we have to really assume, right, that the aliens, if they do exist, they are still bound by the same laws of physics that we are, and this is why, for example, when they built the golden record, right, or when they put on information to help people understand using mathematics, and signals that have been sent out have tried to use things like combinations of prime numbers and things like that. So in theory, at the very baseline, you've got the laws of physics that we all share, and then we can work from that point to try and come up with some kind of universal translator. But
it would just be a matter of figuring out how they interpret those things, I suppose. I mean, because theoretically, I guess it's possible to interpret, like, electromagnetic spectrum a number of different ways. It'd just be...
Yeah, we just blew up your star. Did you notice? Right?
I felt the shockwave.
Did you notice? And we're going to blow up stars until you acknowledge by blowing up a star of your own, and then we will just work from there. Right?
I feel like that's a good idea, Fraser. You should definitely publish that paper for peer review.
Yeah, exactly. So, okay, well, you know what? That was cool. Let's talk about your other topic.
Okay, so that's tsunamis on Mars. So studies have suggested that about 4.5 billion years ago, Mars had enough water to cover 1/5 of the planet. Previous studies have suggested this, but there's some debate on exactly how much water Mars had, whether or not how much of that water was frozen, how much was actually sort of in liquid form. So lots of conversation going out surrounding that. However, one of the things that we could use to help settle this debate is evidence of waves. So obviously, if we have some registration or something that registers this huge, tidal wave on Mars, then it would let us know that, okay, there was a lot of water on the planet at one time. And to that end, recent thermal images of the northern hemisphere show evidence of these enormous tsunamis that occurred, they estimate about 3.6 billion years ago. So they found them because of things called lobes, which are basically huge sedimentary deposits. They're a couple hundred miles in size, long and wide. I guess the oldest flooded an area that is about 300,000 square miles, 800,000 square kilometers. And so that gives us, they argue, really strong evidence that Mars did have this substantial amount of water at one time. And they assert that the tsunamis were likely caused by meteor impacts, because there's very few things that could cause flooding of that size.
That's really interesting. We're just going to try and bring up the picture here. We've got a picture.
Oh, cool.
There
Awesome.
you go. Yeah.
And so the interesting thing, of course, water, Mars, everywhere on Earth where there's water, we find life. And so a substantial amount of water existing on Mars in the past for an extended period helps sort of reinforce the idea that Mars likely could have, or at least it could have, had life.
But you can imagine, right, with Mars, the gravity on Mars is so much lower, and so things like waves and tsunamis would be all the more terrifying because the gravity pulling them down is less. So you could just, I'm not sure sort of what the sizes of these things might have been, but anyone who's seen what was the movie? Oh no, the Impact one.
What is that? There's Deep Impact.
Deep Impact, yeah, it was Deep Impact, right? Where where the asteroid hits the Earth and you get this huge wave that rolls through and it's kilometers high, and it would be devastating. And so you can imagine under the smaller, lesser Martian gravity, they would be even bigger and more terrifying. Oh, here we go. 120 meters high, which is terrifying. Which is the one that hit Japan was about 40 meters high. So, and with these tsunami, right, it's not like you just get this great big wave that breaks and crashes. It's just like the water goes up 120 meters. So start swimming. Yeah.
Or running, as the case may be.
Or running, then
Martian.
swimming. Yeah, then drowning. Yeah. So, I mean, this is just, again, right, more evidence that there was water on Mars for long periods of time, and as you said, wherever we find water on Earth, we find life. So another point of evidence that there was water on Mars for long periods of time.
And so they're still hoping to find, subterranean something, deposits of water that still exist, because obviously, I think we talked about in Weekly Space Hangout, the flowing water that they recently found on Mars, which was really sort of wet dirt, basically, which is better than nothing. But anyway, sort of raises some hope that there might be some subterranean stuff going on under the surface, perhaps, maybe somewhere, might still exist.
Yeah, and this sort of brings us to this place where we have to wonder about whether it's time for a prime directive, right? If there is life on Mars, hiding in some of these places, and as we start to send more and more spacecraft, and eventually colonists, filthy colonists with their bacteria, we're going to hit that life, we're going to, in theory, if our life can survive on Mars, it's going to both be difficult for the science at that point, because we're not going to be able to know what was from Earth and what was from Mars, but also we could actually destroy the life on Mars with our hardier Earth bacteria, or vice versa. Who knows?
That's true. Yeah, and it's one of the things. There's an issue with Curiosity. I don't remember all the ins and outs. It's been a while since I looked into it, but they removed some bit of technology on Curiosity to do some testing or something like that. And there's a person who is in charge of overseeing, basically ensuring that we are not going to contaminate the red planet with any life. Because what we don't want to happen right now is we find evidence of life, and oh no, it's just something that we brought there. These microbes came from Earth, and I mean, a whole bunch of ethical implications and regulatory implications and all sorts of stuff like that. And so it didn't get overseen properly when it was put back on Curiosity and sent off to Mars. So if Curiosity actually does come across hey, look, conveniently, here's a puddle of water on Mars, which is very unlikely. But if it does, it actually, I'm pretty sure, can't interact with it because there's that possibility of contamination. But we'd have to obviously step up stuff a lot if we planned on sending humans there, something like that.
Yeah.
Because we're dirty and have lots of microbes.
Yeah, that's exactly it. That's what I'm saying. Cool. Okay, so we're sort of reaching the end of our... Did you have another story, or were those the two that you brought to us?
That's it. Okay. That's all I have, I suppose. I mean, there's lots of other stuff, but...
Yeah, no, that's totally fine. We've sort of reached the end of the hour, gone a little beyond it, so let's... It
was a good chat. I feel like it was a good chat. We can close down now.
It was good. And once again, I'm sort of... We got a chance to just talk to Mike Brown and Konstantin Batygin, which is just amazing, and they are so much fun. So, I'm big thank you actually to the WSH crew for organizing, as always, the guests, and in this case, getting those two was just an absolute treat. Aim high, WSH crew. You can get some pretty cool guests if you just ask. Cool. So, Jolene, where do people find out more about you and what you do?
So we are Futurism. We cover breaking science and technology news. We do infographics and videos, and This Week in Science is probably one of the things we're really well known for. So just futurism.com, Futurism on Facebook, Futurism on Twitter, Futurism on Instagram, Futurism on Google+. You sort of get the...
I see a trend. Yeah, no, I say the same thing, but yeah.
If you want to email, Futurism,
What's a thing that you guys just recently did that you're super proud of?
A thing that we just did at
Futurism, something you just published in the last day or two?
Something that I published just in the last day or two. Are you getting at something specific that I'm supposed to immediately be like, oh yes, I know this thing that you're talking about?
No, this is a thing we just did that I really like. We did a cool video on Mars or something. But I mean, obviously you did stories about mega tsunamis and the search for aliens. So I think we'll have to go with that. Go to futurism.com Synoptic.com, and
Yes, that's it.
And those should be some of the recent space stories.
Yes, there's the top one is stuff about Europa and alien life and new NASA evidence of how it could exist. So
That
explain things.
I'm intrigued, and the second this show is over, I'm going to go to futurism.com and look at one of the recent stories about Europa and life thereof. That sounds fantastic. And so once again, you can find out more from me if you haven't already. Subscribe to this channel. If you want to support what you're seeing directly, the best way to do that is to go to my Patreon. Go to patreon.com/universetoday, and we've got some sort of different levels that you can join and to try and keep what we're doing as independent and allow us to create more content. We really appreciate all of your support. So once again, patreon.com/universetoday. I got some cool stuff that we're going to be doing. We're going to be doing a collaboration with the folks at Photographing Space. We're going to be teaching you how to take pictures of the Milky Way, and that's all going to be unfolding both on YouTube and on Instagram. So if you haven't already, follow us on Instagram, and we're going to be giving you details on sort of how you can learn to take pictures of the Milky Way, and then we're going to teach you, and then we want to see the results, and then we're going to publish those results in a way that kind of gets the word out as well. So hopefully, if you have never taken pictures of the Milky Way, but you've got some of the gear and you've got the interest, we want to teach you how to do this. So just keep listening, and we will teach you shortly. Cool. Well, so once again, thanks to Mike Brown and Konstantin Batygin. Thanks to Jolene for joining us this week. Thanks to everybody for watching. And apart from the streaming, this was pretty glitch free. So I think this is getting better. Again, please, this is for you. Let us know what we can do to improve. You wanted the film strippy part so you could see that there was other human beings participating in this, and we've done that. So now any other suggestions and feedback, we would love to hear it. All right. We'll see you all next week.